Hey everyone, welcome to Math Talk. I'm your host, Brian Heisler, and today we're going to start looking at what is one of my favorite topics in all of mathematics, and that is number patterns and sequences. I've always loved looking at the patterns of numbers and trying to figure out how to get from one number to the next. And so in this video, we're going to take a look at one type of sequence and how to identify that pattern. So let's get started. Part 1 of patterns and sequences, the arithmetic sequence. An arithmetic sequence is, by definition, a sequence of numbers where the difference between consecutive terms is constant. And what that really means is that, in simple terms, an arithmetic sequence is basically a sequence of numbers where to get from one number to the next or one term to the next, you just add or subtract the same number. So let's take a look at a couple examples to see what that means. Here we have a simple example of a pattern or sequence of numbers. It goes 2, 4, 6, 8, etc. And so to find the pattern, we really want to figure out what are we doing, what number are we adding or subtracting to get from one number to the next. And as you probably already know, the answer to that is 2. You just add 2 every time because 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, etc., etc. And this pattern can be used to figure out really any term or the nth term in a sequence, whether it's the 7th term, the 10th term, the 50th term, whatever term it may be. You just keep adding 2 every time and you eventually get the number you want. So let's take a look at another example. We have an example with a sequence or pattern of numbers that says 25, 21, 17, 13, etc. And so in this example, we see that as the pattern continues, the numbers get smaller and smaller, which means I really am going to be either adding a negative number or subtracting a positive number. So let's take a look. To get from one term to the next, all we have to do is add -4 or subtract 4. Because I prefer positive numbers over negative numbers, I'm just going to say we're going to subtract 4 every time. And if you look at it, 25 minus 4 is 21. 21 minus 4 is 17, minus another 4 is 13, etc., etc. And just like the last pattern, you can continue to subtract 4 every time to find the 10th, the 20th, the 100th, or the nth term in this sequence. It's important to know that what you probably see is that if you continue to subtract 4, eventually you're going to get into some negative numbers, and it's going to continue to be negative from that point on. And that's fine. Your pattern or your sequence can contain positive and negative numbers as long as you follow the pattern of adding or subtracting the same number every time. Okay? So let's look at an example of how we can find the nth term in a sequence, an arithmetic sequence. So we have an example that says or asks, what is the 8th term in this arithmetic sequence below? And it's important to note that this sequence is arithmetic because it allows us to identify a pattern to use to figure out the term. So we go from 5 to 11 to 17 to 23. So my pattern, the values of the numbers are increasing, which means I'm going to be adding a number, a positive number every time. And if you haven't quite figured it out, the things you want to look at are what's the common difference, what number am I adding every time, and once you figure that out, you can continue the pattern to get to your 8th term. So what is the common difference here? It's positive 6. We're adding 6 every time. 5 plus 6 is 11, plus 6 is 17, plus 6 is 23. And we're going to continue that. 23 plus 6 is 29. Add another 6, you get 35, 41, and then 47. And so the 8th term in this sequence is 47. All right, great. So let's take a look at another example to find the nth term in an arithmetic sequence. Again, we're asked to find the 8th term in this sequence, and from what you can see, it starts at 20 and it goes down to 13 to 6 to -1, -8, etc. So we're decreasing the value every time, which means when we're looking at the common difference, it's going to be a negative number. We're going to be subtracting some number. So let's continue the pattern. -8. Well, let's first figure out what the difference is. To get from 20 to 13 to 6 to -1 to -8, I'm going to be subtracting 7 every time. So if we continue that pattern, -8 minus 7 is -15, minus another 7 is -22, minus another 7 is negative 29, which means the 8th term in this sequence is negative 29. And you can see that once I hit negative 1, my pattern stayed negative continuously and will continue to be negative if I were to go and find the 20th, 50th, 100th term, whatever it may be, it's going to stay negative. So I want to issue a challenge problem to see what you've learned. Here is an arithmetic sequence below with 3 missing terms. I want to see if you can take the information you learned in this video to figure out what those 3 missing terms are. If you think you got it, type your answer in the comments below. So I hope this helps as you get the questions on the GED that ask you to identify any missing terms or the nth term in an arithmetic sequence. Be on the lookout for the part 2 video where I talk about the next type of sequence, the geometric sequence. I hope everyone is staying safe out there, and as always, thanks for watching.